everyone. Let's have a look at the application. So I'm not going to look at how we're going to do the practicals here of the experiment. We're just going to say, how do we apply the conservation of momentum and what is it? Now, whenever we talk of conservation of momentum, it means that there is two objects involved and they're going to either collide with each other and then move apart, or it could be that they were together in the beginning and because of an explosion they're going to shoot apart from each other. So we're going to look at a few examples like that. But first let's see, what are we going to use here? So the law that we're going to use here is the law of the conservation of momentum, which states that the total linear momentum in a closed system stays the same. So what does that mean? It means, for instance, let's say I have a car moving in that direction with a certain velocity and a certain mass. So it's got a certain momentum. So let's call that car A. So it's got a momentum, mass times velocity. And you've got a second car moving in the opposite direction with, again, so let's say that's momentum A, let's call second car momentum B, so it's going to have a momentum of B. Of course, we have to say initial, because this is before they collided. So we've got two objects moving in different directions towards each other, they're going to collide in a collision, and they're going to, let's say, they're just going to be shooting away from each other. So it's like almost an elastic coalition. They're going to come, hit each other, and again move opposite directions. So now a good question could be, if you know the speed of the one, or the velocity of the one car, of car A, after the coalition, we can now use that law of conservation of momentum to work out what would be the second car's velocity after the coalition. So in this circumstances, so what we're going to say is we're going to say, all right, let's apply the law of conservation of momentum. And you're going to start by saying the total sum, so you're going to add them together, of the total momentum before the collision would equal the sum, or the total momentum after the collision. Of course, it has to be a closed system. What does that mean? That could be a question I could ask you. What does it mean that it happens in a closed system? Then we know the answer is no external forces. So there's nothing, no air resistance, nothing else. So we're going to just say there's no external forces working on them. It's just a coalition, and they're going to be elastic and shoot again away from each other. Now we could go again. Let's say now they say this trolley's mass equals 1 kilogram, and it was moving at a velocity of 3 meters per second. And the second trolley or car's mass, let's say make that 2 kilograms. And now the question is, if it's moving towards this one at, let's make it 5 meters per second, quite a lot of momentum, and this trolley moved back after the coalition with, let's say, 6 meters per, no, that's too much, let's make it 2 meters per second, what would be this velocity of this first car B? So you always start with this, and then I have to say, okay, what happens before the collision? That means there was the momentum of car A, initial, plus the momentum of car B, initial. And it would then equal momentum of car A final plus momentum of car B final. And what do we have to first do now before we even continue? We have to choose a direction. Very important, because momentum is a vector. So let's say I'm going to choose, for me, I'm going to say, okay, let's decide we're going to use car A, the direction in which that one is moving, as my positive direction. So now I'm going to start applying this. So let's have a look. So this is going to be then mass moment times velocity, mass times velocity, mass times velocity, and mass times velocity. Very important, guys, that when you start your problem, that you do start with both of these. Otherwise, you won't get your formula mark. So to be able to get your formula mark, you have to use at least two of these. The other one that I just changed now, you could have also in between, but that's not necessary. Alright, so now we're going to start and we're going to say, okay, the mass is 1 times traveling at a speed of 3, just check your direction, yes, it's correct, plus trolley B is traveling mass 2 times, careful now, in what direction is trolley B or car B traveling, minus 5 equals, and now I'm going to again say it's the same mass, 1 times, careful now trolley or car A is moving in the opposite direction, so it's times minus 2 plus still 2 kilograms times final speed of car B. And now it's easy peasy, I've correctly applied it, I did use the right directions, and let's say, so we're going to get, we've got here a 3, minus 10 equals minus 2 plus 2 V final, and that gives me, looks like 9, 3 minus 10 is minus 7, that goes across, minus 7 plus 2, that gives me a minus 5, plus 2, yeah, minus 5, equals 2 final, so V final is then minus 5 divided by 2, and the final velocity of car B equals 2,5 meters per second. And you see that I do have a minus here, which in this case, let's have a look. Am I correct? We've got a minus there, so we've got a minus there for car B. Car B was traveling in that direction. Now, why do we have a wrong minus here? So we've got plus 2 times VB final. That comes over, so that becomes a plus 2. That's a minus 5, so it's got a minus 2,5 meters per second, and that means that car B will then be shooting back at the opposite direction, because I've chose that direction as my positive, so it looks to me like even though it's going to hit this car, it's going to continue moving in this direction. So I'm going to say 2,5 meters per second to the right or to the left. If I chose that right as my positive, that means that it will keep on moving in this direction. It's not going to bounce back as I thought, and that's why I get a minus for my answer. Alright, so that is the change of conserving of momentum during any collision or explosion. Now let's have a look at a different example. Okay, so you're always going to have two things. Okay, second example I want to show you looks like this. Alright, they say that this comes out of a previous exam paper as well. Now what they've got, a trolley with a mass of 3 kilograms moving in a certain direction with 3 meters per second. A 1.5 kilogram mass gets dropped onto the trolley with a certain velocity with which it hits the trolley there. So you see 2 objects. I've got a before coalition scenario, and then I've got a after coalition scenario where that mass is now on top of this mass and they're moving in the original direction. So the question is, they said to you, calculate the speed or the velocity of the trolley. Let's call this one trolley X, that one is trolley Y, of trolley X immediately after the object has fallen onto it. Alright, so let's start. So immediately you say to yourself, alright, I've got the sum of the momentum before coalition, and that would equal the sum of the momentum after the coalition. Again, what is it? So let's say we've got X. Now I'm going to say, alright, that's the mass times the velocity of trolley X plus the mass times the velocity of trolley Y equals, and now because they're going to be stuck together, they're going to be the 2 masses added together, and they are traveling at a certain velocity. So let's say a final velocity. And now I'm going to start. So what do? We choose, let's say again, let's say right. If they give you any drawing or something that I have on the exam paper and it shows it's going to the right, then you can use the direction as saying to the right is my positive direction. Alright, so we've got the mass, 3, times the velocity of X, it's traveling at 3, plus mass, 1,5, and now for the catch. If this velocity is completely vertical, does it have a component velocity in the horizontal direction? Let's see, going to the X plane, no, 0. So for something being dropped completely at a 90-degree angle towards something moving in that direction means that it's got no 0 velocity, a component velocity horizontal. Alright, equals the 2 together, which is then 4,5, V final, and now you can easily work that out. So we've got a 9 here, plus the 0 equals 4,5. Final velocity of X and Y moving together, and that gives me then a 2 meters per second. It's a positive answer, which tells me it's moving towards the right. Alright, so the moment you get a question where you see, and that is going to be most of the questions in the papers at the end of the year, guys, which has to do about momentum, and that is either coalitions or explosions. In the case of an explosion, the advantage is that both of them were still standing still before the explosion. So your momentum before would then equal 0, but still show it. You have to start with your formula, do first, then do this, get your mark for your formula, and then you would say, okay, they are standing both velocity 0 because they were standing still, so that equals total momentum before as 0. Great. Go and practice. Believe in yourself. You can do this.